Fakultas Teknik Geologi Universitas Padjadjaran merupakan lembaga pendidikan tinggi yang menyelenggarakan dan mengelola 3 program studi, yaitu program sarjana dan program pascasarjana yang terdiri atas program magister dan program doktor dengan didukung oleh 8 orang profesor dan 37 orang dosen sebagai staf pengajar. Fakultas Teknik Geologi dengan visi menjadi fakultas yang berstandar internasional dan bermanfaat bagi masyarakat. Salah satu tugas pokok dalam kurikulum teknik geologi adalah menciptakan lulusan yang memiliki keunggulan dalam kemampuan lapangan, sehingga kurikulum teknik geologi dikembangkan secara terpadu dengan muatan desain penelitian, baik berupa pengetahuan, keterampilan maupun pengalaman penelitian dalam bidang geologi, sehingga mahasiswa bebas memilih dengan outcome yang lebih baik sebagai bagian dari program Merdeka Pembelajaran. Teknik Geologi Universitas Pajajaran merupakan lembaga pendidikan tinggi yang menyelenggarakan dan mengelola 3 program studi, yaitu program sarjana dan program pascasarjana yang terdiri atas program magister dan program doktor, dengan didukung oleh 8 orang profesor dan 37 orang dosen sebagai staf pengajar. Fakultas Teknik Geologi dengan visi menjadi fakultas yang berstandar internasional dan bermanfaat bagi masyarakat. Salah satu tugas pokok dalam kurikulum teknik geologi adalah menciptakan lulusan yang memiliki keunggulan dalam kemampuan lapangan, sehingga kurikulum teknik geologi dikembangkan secara terpadu dengan muatan desain penelitian, baik berupa pengetahuan, keterampilan maupun pengalaman penelitian dalam bidang geologi, sehingga mahasiswa bebas memilih dengan outcome yang lebih baik sebagai bagian dari program Merdeka Pembelajaran.
Alright, good day, ladies and gentlemen. Welcome to Webinar International Series number 2, Paleoceanography and Global Climate Change. It's such an honor for me to welcome you here in this event today. I'm Kamalo Jayanti, your host today. I would like to extend a very warm welcome to all of you, both on Zoom application and also YouTube Live. This webinar series is a part of 62nd Natalis or anniversary of Geological Engineering Faculty events that held every Saturday. Before we start, let us hear the national anthem of Indonesia, Indonesia Raya.
Indonesia, tanah airku, tanah tumpah darahku. Di sanalah aku berdiri, jadi pandu ibuku. Indonesia, kebangsaanku, bangsa dan tanah airku. Marilah kita bersatu, Indonesia bersatu. Hiduplah tanahku, hiduplah negeriku, bangsaku, rakyatku semuanya. Bangunlah jiwanya, bangunlah badannya untuk Indonesia Raya. Indonesia yang merdeka, merdeka, tanahku, negeriku yang tercinta. Indonesia yang merdeka, merdeka, hiduplah Indonesia Raya. Indonesia yang
Now, I would like to greet Professor Estintin Yunisi, Vice Dean of Learning, Student Affairs, and Research of Geological Engineering Faculty, to deliver opening remarks. Professor Estintin Yunisi, please welcome.
Okay, thank you very much, Ibu Kemala. Good afternoon, everyone. In the name of Allah, the most beneficent and the most merciful, may peace, mercy, and blessing of Allah be upon you. Greeting to all of us. Dear Dean, Vice Dean, Head of Department, Head of Study Programs, Managers of Faculty of Geological Engineering, Professors, lecturers, colleagues, researchers, students, ladies and gentlemen. On behalf of Faculty of Geological Engineering, Universitas Pajajaran, I would like to express my sincere gratitude and welcome you to International Webinar Series 2 as part of 62nd Faculty of Geological Engineering Dies Natalis event series, today, October 2nd, 2021. Moreover, I honorably welcome our invited speakers. First, we have Professor Minoru Ikehara from Japan Drilling Earth Science Consortium and IODP Section Executive Committee of Center for Advanced Marine Core Research from Kochi University, Japan. Welcome, Sensei. And second, we will have Associate Professor Dr. Shun Chionobu from Faculty of International Resource Sciences, Akita University, Japan, and also as the IODP section as nanofossil specialist. And we will also have our colleague, Dr. Tekuyan Walyana Muda Iskandarsya, our lecturer, Faculty of Geological Engineering, Universitas Pajajaran, as invited speakers. It is pleasing to note that the agenda of this webinar series cover a wide range of interesting topics related to all theoretical and practical aspects. It is my hope that the international webinar series today with theme Paleoceanography and Global Climate Changes would be able to achieve its objective in providing an effective forum for academicians, researchers, and practitioners to advancing knowledge, research, and technology to conserve the Earth. As I know, the study of natural climate change is important for many reasons. From knowledge of climate change of the past, as we know as paleoclimate, is necessary in order to better model future change. Paleoceanography provides information on rate of process of environmental change in the past, and in providing this information, paleoceanography enables us to use the past in order to gain information on possible future climatic and biotic development. The past is the key to the future, just as much and maybe more than the present is the key to the past. Last but not least, my deepest gratitude goes to the advisory board and organizing committee who have supported the success of this webinar. The committee has organized a vibrant scientific program and is working hard to present highly respected and internationally notorious speakers to lead it. And although we try our finest to be professional, on behalf of Geological Engineering Faculty, please accept our sincere apologies should there be inconveniences that occur before, during, or after the event. I wish you a very productive webinar with exciting and encouraging discussion and exchange of knowledge so that together we can anticipate a future of groundbreaking knowledge, research, and technology to conserve the Earth. May God bless us all with good health to make this event a successful and enjoyable one. Thank you very much.
Thank you for your wonderful remarks, Professor Ais. So we have invited three speakers who are competent and experienced. They are Professor Minoru Ikehara from Japan Drilling Earth Science Consortium and IODP Section Executive Committee Center for Advanced Marine Core Research, Kochi University, Japan. Also, Associate Professor Dr. Shun Chionobu from Faculty of International Resource Science, Akita University, Japan, IODP 303 306 nanofossil specialist. And the last is Dr. Tukuyan Waliana Muda Iskandar Shah from Faculty of Geological Engineering, Universitas Pajajaran. So, all right, now let me invite our moderator today is Dr. Eng Santi Dwi Pratiwi. Good day.
Yeah,
Dr. Santi.
yeah. Thank you very much. Yeah, thank you very much for your welcome today. So, good afternoon, everyone, and welcome to today's session. So, my name is Santi Dwi Pratiwi. I will be moderator for this sessions. As you know, for today we have second webinar series with the theme in the Paleoceanography and Global Climate Change. And also for this webinar, we hope we can conduct the increased insight and knowledge about geology, especially in the field of paleoceanography and climate change. So before we starting, allow me to introduce the speaker presenter. The first speaker is from Kochi University. Professor Minoru Ikahara. So I will introduce first for the biography, for the file. Please waiting for the CV. So maybe I can share. Yeah, okay. Yeah, okay, sorry for the time. So for the first is about scientific ocean drilling and southern oceanography, paleoceanography. So the speaker is from Japan Drilling Earth Science Consortium JEDES and IODP Section Executive Committee, Professor Minoru Ikahara, with the expert in the paleoceanography and organic geochemistry and also in the marine geology. So for the education, he was graduate from the Tokyo University as a doctoral in the Department of Geology, and for the professional activity, as you can see here, is many experience in the, especially in the International Ocean Discovery Program, and also Professor Minoru Ikahara is associate editor in the Ireland Art Journal, and until now is still the executive committee in the IODP and JEDES executive committee. And for the selected cruise experience, many experience in the International Ocean Discovery Program, and including using a CQ ship from Japan, seaboard as a seaboard organic geochemistry, and also as a paleoceanographer. So please welcome to our first keynote, Professor Minoru Ikahara. Time is yours.
Good afternoon, everyone. Thank you very much for inviting me to join the international webinar series. So today I would like to show some topics. So can I share the slide?
Yeah, Sensei.
So, okay, can you see the first slide?
Yes, Sensei.
Okay. Today's title of my talk is Scientific Ocean Drilling and the Southern Ocean Paleoceanography. So I'm working at the Kochi University in the Kochi Call Center, Japan. So let's start my talk. Here are today's topics. So early part of my talk, I'd like to introduce International Ocean Drilling Program, IODP, and there are also some important facility, a repository and a drilling platform. And also second half of my talk, I will show you some topics which will focus on the Southern Ocean paleoceanography. Okay. So IODP is one of the most successful international collaborative research program, which have history of over the 50 years. So IODP has made a short movie and posted movie on YouTube. So let's take a look. Short movie. So
before, I think we're going to see a significant number of casualties.
Tonight, the largest volcano has been discovered. And I know what you're thinking, how could the largest volcano on Earth stay hidden? This might be hard to hear, but apparently we know next to nothing about our own planet.
If we want to fully understand climate change, earthquakes and tsunamis, the history of life, and the evolution of our planet, we need to study the vast, largely unexplored area beneath the ocean floor. Here, rocks and sediment deposits act as a logbook for Earth's history, recording both gradual changes and sudden events over the past several million years. Scientists have expanded the frontiers of human knowledge by drilling core samples from each of the world's ocean basins. Their work is far from done. The new International Ocean Discovery Program, or IODP, is carrying this work forward with a focus on 4 critical research themes. There is no better place to study Earth's climate history than the ocean floor, where climate records reach back 10 times as far as the oldest ice cores. By understanding the past, we can more accurately predict the future and assess how the planet will respond to increased carbon emissions, warmer air and water, and more acidic oceans. Scientific drilling can not only help us survey life on, but also in the seafloor. By studying the communities of bacteria and other microbes surviving in this harsh environment, we can better understand how life might have begun and can learn to recognize the kinds of life we might find on other planets. Deep beneath the Earth's crust, the molten mantle has undergone dynamic changes over millions of years and is still evolving even today. A better understanding of these processes can teach us about the nature of plate tectonics, seafloor spreading, and continental uplift. The Earth can also move suddenly, often with disastrous results for human societies. Earthquakes, landslides, tsunamis. What causes these geohazards? With further study, we may yet be able to discern patterns and read the signals in advance. Extra warning could mean the difference between life and death. The ocean floor is a rich source of information for the worldwide scientific community, but accessing it is not easy. IODP relies on specialized vessels and equipment to recover samples from the deep. There's the JOIDUS Resolution, the US-based workhorse of the program. This flexible, adaptable vessel has been drilling samples and providing data for nearly 30 years. A thorough refit has set her up for decades of future service. The Chikyu, operated by Japan, is a deep-water drill ship purpose-built for scientific drilling. Her advanced capabilities offer the best chance for one day reaching the planet's mantle. And a consortium of European countries provides mission-specific platforms that can access areas off-limits to the other two vessels. For example, icebound seas or shallow waters. The latest innovation at IODP is the use of sub-seafloor observatories that can monitor crucial processes such as changes in temperature, pressure, and fluid flow over various timescales. Many are capable of connecting to regional networks to serve data in real time. IODP generates vast amounts of new samples, data, and experimental results. A network of facilities helps preserve this knowledge for future generations, making it openly accessible to the global scientific community. Repositories in the US, Japan, and Germany store and curate cores and send samples all over the world upon request. Websites, newsletters, and social media portals keep the public informed of the latest scientific discoveries, while specialized education programs train science teachers and instill passion for discovery in young minds across the globe.
To represent our drill pipe to drill into this paint.
Like the ocean itself, the sea floor covers nearly 3/4 of our planet. And today, more than ever, we need to discover all it has to tell us about our past and use these lessons to inform our future.
Okay. So we have three types of platform: laserless drilling vessel and the laser drilling vessel GQ, and the mission space platform in the IODP program. And also, repository is another important facility in the IODP program. So Kochi University, Kochi Core Center is one of the core repository in the IODP program. So Kochi Core Center is covered in the western part of Pacific and the almost Indian Ocean. And also US Texas A&M University is covered by most of the Pacific and the Southern Ocean. And also Bremen Core Repository in the Germany is covered almost Atlantic Ocean and the Arctic Ocean. And so Kochi Core Center is operated at Kochi University and the Jamstec. So this is building, and now I'm here. And also in Kochi Core Center, Kochi Core Repository is stored a huge number of the deep sea sediment cores from Western Pacific to Indian Ocean, more than 140 kilometer length. And also drilling platform GQ is very important facility in the IODP program. So if you want to see the detail, please check the YouTube site in here. And also, this is one of the picture of our current expedition. So we have done a short expedition to drilling off Shikoku Island. So this is a SCORE program. It just a domestic program, not IODP program, but we can use the drilling vessel Chikyu to collect a continuous sedimentary lake near Japanese island. So our target is Kuroshio, and late August this year, we have a 10 days expedition as completed done. So we have a short movie, 3-minute movie of our expedition. So this is a good chance to see the Chikyu expedition. So I'd like to show the movie. Right. So we have collected 300-meter drill core from the northwest Pacific, and now we have a start to investigate the oceanographic study to reconstruct cross-shore variability during the quaternary. And okay, in the IODP program, we have so many targets. So target including the climate and the ocean change. Also, current IODP program will finish in the 2024. So we need to prepare the new program, new international program for scientific ocean drilling in the world. So our community just summarized the long-range plan for the future scientific ocean drilling after 2024 through the 2050, more than 25 years long-range plan. And also we have planning to renew the future international drilling program after 2024. So this is a scientific framework of the scientific ocean drilling. And here is 7 strategic objective in the future plan. And also related to climate change, 2 items, Earth is climate system, and the tipping point in the Earth is history is included in the 7 objectives, 7 major objectives. So climate change is one of important target in the scientific ocean drilling. Okay, let's move on to the second topics of my talk. Southern Ocean Paleoceanography. Okay, this map showing the sea surface temperature distribution of the surface ocean. So when I studied the global climate change, I focus on the 2 phenomena. So one is the heat. So this map shows the in the Pacific, one pool is here, around here. And also its transfer process to the from tropical Pacific, tropical Indian Ocean to the mid latitude, very important to control the climate change. So this is a schematic figure diagram. So heat source is here, means the tropical Pacific. And here's a heat engine and the transportation system, which is mean the cross-shore current in the Pacific. And also source and the transportation system is controlling the climate change. So this is very important. And also, the other important thing is the Antarctic cryosphere. So there are huge Antarctic ice sheet and many icebergs, and also there are so-called surface water in the Antarctic Ocean, Southern Ocean. So these items act as cooler for the Earth's climate. So today I will focus on the Southern Ocean Antarctic cryosphere to control the climate change. So this is a schematic picture of the Antarctic cryosphere. So central part of the huge volume of the ice on the Antarctic continent. And also sea ice is also important item in the cryosphere system. And also Antarctic circumpolar current is flowing the surface of the Southern Ocean. So that surface largest surface current is major boundary between the tropical ocean and the Antarctica. And this is a schematic diagram, the global overturning circulation made by Tally. So many major ocean currents flow in the Southern Ocean like this. Purple color show the upper oceans and the thermohaline circulation. Red show the denser thermocline and the intermediate water circulation. Orange shows the Indian deep water and the Pacific deep water. And green show the North Atlantic deep water here. And the blue show the Antarctic bottom water from Antarctic continent margin. So Southern Ocean is a place the link between three major oceans, North Atlantic, Indian, and the Pacific Ocean. So Southern Ocean is very important area. So it's very important to understand the variability of ocean circulation in the Southern Ocean. So this figure shows the surface temperature distribution map in the Southern Hemisphere. So there are many oceanic fronts. STF subtropical front is a major boundary between tropical ocean and the Antarctic surface system. And also polar front is a major front. WSI means the winter sea ice limit, and the SSI show the summer season sea ice limit. And the WG show the wetter gyre, one of the polar gyre system. And we have IOTP proposal 918, which is focused on the South Indian sector of the Southern Ocean. Title is Paleoceanography Paleoceanography. Short title is Southern Ocean Climate Evolution. So I will show some slides related to this IODP program, IODP proposal. To develop this IODP proposal, we need to site survey. So we have done 5 times site survey cruise using the Japanese vessel Hakuhoma. So this is one of the example for the 2019 cruise. So now we are focused on the western part of Indian sector of Southern Ocean and here. This map showing the location of the proposal site. We focus on the two topographic high in the western part of Indian sector of the Southern Ocean. Here is a Delcon rise, and the southern part of the topographic high is Conrad rise. So we have selected 4 primary sites from here. And this is a schematic diagram to summarize transect drilling in the Southern Ocean. And upper panel shows the north-south cross-section in the Southern Ocean to show the water mass structure and the oceanic front here. ACC flowing here. And the lower figure shows the global climate change, which is shown by oxygen isotope variation in the deep water. back to the 20 million years ago. Here's the 4 primary sites. Here is the 2 sites from the colon rise and the 2 sites from colon rise. We expect that during these 2 sites on the colon rise will allow us to investigate back to the Miocene. And also the other 2 sites from the colon rise, it's expected that the high resolution paleoceanography of Pliocene and the Pliocene can be performed by taking advantage of the high sedimentary shoal sediments. In our proposal, we propose 2 major hypotheses. One is reorganization of the Southern Ocean circulation. The sea ice coverage had a major impact on the global climate change in the mid to early Pleistocene through the altitude change of Eastern Antarctic ice sheet and the subtropical climate shift. Second hypothesis, variation in the Antarctic circumpolar current determine the physical and biological characteristics of the oceanic carbon pump and atmospheric CO2. So I will focus on hypothesis 1. During our site survey cruise, we have done multi-channel seismic survey on the southern part of the Conrad Rise. So we have a 12 seismic profile line here. And this is an example of profile from central part seismic line here, and the north and the south cross section. As you can see, the sediment wave structure we observed in the upper sedimentary unit A around here, and there are major unconformity, and also unit B is here. So our first important findings during the site survey is discovery the sediment wave structure on the abyssal floor of the Conrad Rise. So this figure shows a close-up seismic profile. So here is a typical sediment wave structure in the unit A and the unit B, and the unconformity major boundary. And according to our observation in this area, sediment wave structure only observed at the water depth of 2,400 meters to 3,400 meters. And wavelength is about 1 kilometer, and the wave height is about 100 meters. And interestingly, there is no sediment wave structure in the lower sedimentary unit B. So I don't know if there are big sand dune sand wave structure in Indonesia, but in Japan, there are huge large-scale sand dune in the Tottori prefecture like this. This is a typical photograph of the Tottori sand dune. This is a scale 100 meter. Here is also humankind scale. We can climb up the high of the sand dune. So based on our survey, there are underway underwater landform that looks like giant sand dune in the deep sea of the Southern Ocean. So How was this underwater sand dune created? First, we focus on the sediment core from Natalis. We have a 10-meter length piston core from Natalis here. And sediment composed of pure diatoms. This is the SEM image of sediment. Almost sediment particle is diatom. And also bulk density is around 1 to 1.1 gram per cubic centimeter, like of seawater density. And also sedimentation rate of this core can be estimated as 27 centimeter per kilo years. So this is a huge high sedimentation rate in the periodic setting. And also we check the physical condition in the modern Southern Ocean. This diagram shows the current speed, and also lower panel show the cross-section, north-south cross-section over the Natalis area. And also here is a current speed distribution. So previous physical oceanographic and the modeling study revealed that the ACC Antarctic circumpolar current flow reached to the seafloor on the Natalis. And then here is orange color show the area of our observation area of sediment wave structure. So we concluded that the sediment wave of Natalis are formed under the influence of the Antarctic circumpolar current. So sediment wave structure can be used as a direct physical proxy to reconstruct the past ACC flow area, flow timing on the Natalis. And back to the seismic stratigraphy. Here is summarized figure of the seismic profile. So unit A shows the typical sediment wave structure, which means the strong ACC flow. And unit B, there are no sediment wave structure. This means that no ACC influence in the sedimentation process on the Natalis. So here is a big difference. So we expected that the ACC and the related oceanic frontal system are significantly modified during this timing, which is 1.5 to 2 million years ago. So this timing is estimated by sedimentation rate of a piston core. And this is important diagram in our paper 2014 Marine Geology. Upper panel show the schematic diagram for the warm Pliocene condition, and the lower panel show the quaternary. So ACC flow is located in the south of the Natalis. So Natalis sedimentation is no influence by ACC flow. However, during quaternary, ACC flow directly to affect to sedimentation process on the Natalis area. And also ACC shifted to north this timing amid Pliocene. So we proposed one of the hypotheses that the ACC was migrated to the north during the early to mid Pliocene. And also migration of the ACC significantly affected reorganization of the global ocean circulation. And this is a figure from Sunganuma-san paper 2014 Continental Science Review. They tried to reconstruct the elevation change of East Antarctic ice sheet by using the cosmogenic nuclide proxy of rock sample from East Antarctica. And this is important figure. Here's the estimated age and the elevation here. And it was reported that the significant shrinkage of East Antarctic ice sheet was occurred during the Pliocene to Pleistocene. And timing is important. 1.2 million years ago, here's a large drop for the East Antarctic ice sheet elevation. So this is a record from East Antarctic rock sample. And the Sunganama-san paper showed this kind of diagram. So this is schematic representation of the reorganization of Southern Ocean circulation. This is like late Pliocene. Upper panel show the Pliocene condition, surface ocean condition here, and the cross section of the Southern Ocean and the East Antarctic ice sheet. And the lower panel show the quaternary condition. So Pliocene warming period, water transport from the Southern Ocean is enhanced to the Antarctic area. So this water vapor transportation to develop the large amount of ice sheet during the warm Pliocene. So northward shift of the ICC and Antarctic cryosphere expansion were related to the significant shrinkage of the East Antarctic ice sheet. So based on our observation in the Southern Ocean, so our new findings of sediment wave history strongly supported these hypotheses for reorganization of the Southern Ocean circulation. So now we try to make a sea surface temperature stack in the Southern Ocean back to the 5 million years ago, based on the published and unpublished sea surface temperature record. So you can see that there are two-step cooling in the Southern Ocean. One major cooling is 3.5 million years ago during the late Pliocene. Second one is 1.5 million years ago, and here. The sea surface temperature change in the Southern Ocean are not timed to coincide with a major climate change event in the Northern Hemisphere, such as mid-Pleistocene transition and the intensification of Northern Hemisphere glaciation are here. So we believe that the second cooling event around 1.5 million years ago is associated with a major reorganization of the ocean current in the Southern Ocean. So this is our new hypothesis. So we hope to test our hypothesis of ACC and East Antarctic ice sheet evolution history by transect drilling across ICC in the Southern Indian Ocean in near future. So this is a brief summary of my talk. First, IODP plan to renew for future scientific ocean drilling after 2024. You can check the new science framework from IODP website. And we found sediment wave structure on the collateralized in the Southern Indian Ocean. This is an important findings to reconstruct the long-range oceanographic evolution in the Southern Ocean. And also migration of the Southern Ocean frontal system in the early Pliocene might be linked to Antarctic cryosphere expansion and global cooling. So we want to test using a new drilling core from sediment in the Southern Ocean. So yeah, probably this is the final slide of then my talk. Thank you very much.
Yeah, thank you, Professor Minoru Ikehara. So now we will have a time for the question from the audience. So for the audience, if you like to ask a question, please raise your hand by the click on the raise hand icon in the middle right of the screen, or also you can writing in the chat room. So Sensei, for the first question is sediment wave on the Conrad rise due to compression, tectonic activity, or anything else?
Excuse me, please, Bang, again.
Yeah, so for the sediment wave on the Conrad rise due to compression by tectonic activity, or that have such kind and anything to make that sediment wave is changed, in the Conrad rise?
Yeah, sediment wave structure, yeah, one of the evidence for the large-scale oceanic changes, I think. So, yeah, we think that one of the proxy to direct proxy to physical condition, the past oceanic circulation change.
Oh, okay, so
is it answers for the
yeah, okay.
question?
So that is mean related with the global tectonic event, yeah, Sensei. Not so influenced by the climate change event, Sensei.
Yeah. But also climate change control to the ACC front migration. So sediment wave, we would like to use the sediment wave structure to reconstruct past ACC position.
Okay. Yeah. Okay, Sensei. Thank you. And for the second question is that the drilling project get the core in the every layer unit or at the curtain depth only? So for the drilling project, for the CQ or geodesic restoration, usually for the core, we drill in the every layer unit or just in the depth only, in the curtain depth, Sensei, for the core sample.
Sorry, once again, please.
Yeah, Sensei. So in the drilling project, yeah, if you're using geodesic or CQ, so usually for the drilling core sample, is that in the every layer unit of the core sample or at the curtain depth only? So for example, it's just in the 100 meter on in the 200 meter, or it will be in the every layer unit, Sensei, for the sediment?
Yeah. We can use the all sediment core from drilling. So you mean the score program?
No, I mean the depth of the core.
Deep core.
Yeah.
Yeah, of course, we can use the deep sediment core back more than 1,000 meters.
Okay. So that means it depends the purpose of the drilling program, yes, Sensei, case by case.
Yes, case by case, depend on the sedimentary structure. Yes, and also safety issue is important to check the drilling target depths.
Okay, Sensei, thank you. So, Mr. Hedison, do you have any more question? Or is that clear, Pak? Oh, okay, yeah. So it's clear. So, and another question, Sensei, related with the IODP program, we also want to ask, is that have opportunity for another Indonesian researcher or student to join IODP program using JDS or using CQ ship, Sensei?
Yeah. this is an important issue, and yeah, probably we can make a kind of a collaboration program between JDESC and the Indonesian university, or some kind of a consortium. So yeah, maybe we can invite young students for Indonesian university.
So usually is for master, doctoral, or for undergraduate students as can join for that expedition?
Yes, we probably graduate student is join the IODP expedition officially.
Okay, so how about the rules, Sensei? So that means our student must stay in the Kochi University first, or they can come when they want to do for the research or some kind like that, Sensei?
Yeah, of course. Some young student in Indonesia, we are welcome to stay and visit the Kochi Core Center, Kochi University, to use the IODP cores. We have a lot of sediment and rock cores from the Western Pacific and the Indian Ocean. So everyone can use this sediment core. So if you want to use, and if you interested to use the cores, yeah, please visit, please send to sample request.
Yeah, okay, Sensei. So that means we also can request for the sample, or we can also sending our student to stay in the Kochi University, yes, Sensei?
Yeah.
Okay, I think that is good opportunity for us. And now for the next question, Sensei, sorry, is one more question. So oceanographic research by Kochi University is far enough from Japan even to reach Antarctica. So the question is how far the result of those researchers are for the scientific interest of the Japan, Sensei?
Okay, that's a important question. So this is depend on the scientific target, scientific objective. So we need propose to use a research vessel, Japanese research vessel, and we have evaluation process in the University of Tokyo. If our proposal pass to the evaluation process, we can use the research vessel. We can go anywhere in the world.
Okay, so usually is how long, Sensei? Is 1 year or around 1 year or 2 years, Sensei, for the
evaluation process?
Yeah. Yeah.
Yeah, we have a evaluation process every 3 years. We have a chance to submit a proposal every 3 years to the University Tokyo.
Yeah.
And also Japanese vessels Hakuhoma can go to the international water maximum cruise length is about half a year.
Yeah, okay, so it's around 6 months for the
6 months, 5 months.
Yeah. Examination and some kind of the process. So from the audience, is that still have question for other students or from the lecturer or from the researcher? Yeah, I think is no more questions, Sensei. So yeah.
Okay, thank you very much.
Yeah, thank you very much for your time, Sensei. Maybe if I can conclude for today is about IODP and what is important drilling project in the JDS or IODP expedition to reconstruct about the global climate change and also for paleoceanography inside of the understand about a big history of the Earth in the past climate to better predict and model the climate change in the future. So Professor Minoru Ikehara, maybe before we are closing for your presentation, you want to take a picture, Sensei? Is that okay?
Yeah, sure.
Yeah, okay, Sensei. So maybe Miss Kamala, can you provide for the take a picture? Yeah.
All right, so now we'll take a photo together. So all of the participants can turn on your camera. Then the operator. Okay, let's take a photo. 1, 2, give a big smile. 3. Okay, once more. 1, 2, 3. All right, thank you very much for all the participants. And thank you for Professor Minoru Ikehara for the great explanation. And as our appreciation, we will give a certificate that will be given by Dean of Faculty of Geological Engineering, Professor Mega Fatima Rosana.
Yeah, thank you very much, Ibu Kamala. Professor Minoru Ikehara, on behalf of our faculty, we would like to present you a certificate of appreciation as invited speaker in our webinar series during our inauguration for our faculty. Please receive our certificate digitally, as you can see on the right side. Maybe the original later we will send it to you if it's necessary. Thank you very much for your contribution to our faculty. Thank you.
Thank you very much.
Okay, let's move to the next speaker. For the second speaker is Associate Professor Dr. Shun Chiyonobu from Faculty of International Resource Sciences, Akita University, Japan. I would like to invite Dr. Engsanti Dwi Pratiwi as our moderator today.
Yeah, okay, thank you very much, Ms. Kamala Jayanti. So now for the second speaker is Dr. Sun Chiyonobu from Akita University. So please let me introduce a little bit about Chiyonobu Sensei. So for the topic is about reconstruction of paleoceanographic condition in the Pacific Ocean over the last 500 kiloyears based on calcareous nanofossil assemblage. And Dr. Sun Chiyonobu is from Faculty of International Resource Science and also as nanofossil specialist in the International Ocean Discovery Program, Expedition 303 and 306. And for the specialization, Dr. Sun Chiyonobu is specialized on the Earth system and resource engineering, and also in the paleontology and stratigraphy. So for the education, he was graduate from the Akita University for the until undergraduate, and then continue to the doctor and master in the Tohoku University. And also for the professional activities, Dr. Sun Chiyonobu was a research internship of innovative technology for the Earth as a researcher in there. So please welcome to Dr. Sun Chiyonobu. Time is yours. Thank you, Sensei.
Thank you, Santi-san. So nice to meet you. I'm Shun Chiyonobu. So now I share my presentation. So can you see my presentation, Santi-san?
Yes, Sensei.
So now I change the full screen. So can you see? So thank you for giving the opportunity in this presentation. So it's my pleasure to be able to talk about calcareous nanofossils in this international webinar series of the ceremony of Pajajaran University. So today I talk about reconstruction of the paleoceanographic conditions in the Pacific Ocean over the last 500 kilo year based on the calcareous nanofossil assemblages. So first thing, I have the self-introduction. So now Santi-san introduced my jobs. So I graduated at Akita University in 2002, and I have some of the jobs, for example, drilling engineer or petroleum geologist. And now I am in the Akita University as associate professor of petroleum geology. I have some of experience of ocean drilling project programs. So I joined IODP 303, 306, North Atlantic climate changes, and also 322 and 358 and 365. So this ocean drilling project derived in the Nankai Trough seismic zone. So in this ocean drilling project, I am nanofossil stratigrapher. So nanofossil stratigrapher have the job and the stratigraphic correlate using the nanofossils. So today I talk about mainly the nanofossils. So this is today's content. First thing, I showed what's the nanofossils, and the nanofossils are the proxy of oceanographic conditions. And finally, I showed the case study of reconstruction of paleoceanographic conditions based on my PhD studies in the Pacific Ocean. So first things, I introduced what the calcareous nanofossils, calcareous nanoplankton. So these figures show the calcareous nanoplankton and fossils. So these specimens is one cells of calcareous nanoplankton, living plankton. And this figure, this photograph showed the nanofossils. So nanofossils mean the scale of the nanoplankton. So one scale is one calcareous nanofossils. So calcareous nanofossils have the lot of feature like this. So this is a very interesting shape. So like COVID virus, like this. So calcareous nanoplankton live in the world oceans, and these species have the blooming in the springtime or autumn time. So blooming feature is like this. So these feature can see the Landsat scales. So, and calcareous nanofossil and plankton have characterized a synchronous of extinction and occurring, and a high evolutionary rate throughout the geological time scale. And we can make the slide of nanofossils easily. So it is a easy preparations for the observation. So these character is better for the stratigraphic researches. On the other hand, nanoplankton plankton and nanofossils is a widely distribution in the world oceans. And they have the sensitivity for the ocean condition. And they have characterized carbon cycles and sulfur cycles. So they have the relationship with the carbon cycle and the sulfur cycles. So these facts is a very good proxy for the reconstruction of paleoclimate. And I briefly showed about the proxy. So calcareous nanofossils as a proxy of the ocean conditions. So Okada and Honjo, Okada sensei and Honjo sensei clarified the distribution of calcareous nanoplankton in the ocean. So this figure showed the latitude, so equator to northern hemisphere, and the vertical axis shows the sea water columns. So in the photic zone, so 0 means the sea surface, and 200 meter means the bottom of the photic zone. So several species were clarified distribution in the sea water column. For example, this species, Rhabdosphaera clavigera, living in the middle latitude, between the 10 degree to 40 degree northern hemisphere. And this species living in the upper photic zone, so above of 100 meter in sea surface water. On the other hand, this species is Florisphera profunda. Florisphera profunda living in the equator to high latitude region, but this species living in only lower photic zone. So lower photic zone means below the 100 meter depth. So this species like dark light condition in the sea surface waters. Also, Tierstein showed the distribution pattern of several living plankton. So he showed the relationship with temperature and the light power and nitrate and phosphate. So for example, genus Umbellosphaera, so these species living in the shallow water in sea surface. So this species like high temperature. So this species means that here, these species like high temperature and a strong light power. So it means live in the most surface of seawater. On the other hand, this Florisphera profunda. Florisphera profunda living in the deep position in the sea surface, so like below the 100 meter in sea surface water. So these species like the high nutrient levels, so high nitrate and high phosphate zone is like it's like this. So Florisphera profunda like the high nutrient, but they like low temperature and low light powers. So this is a schematic images of the distribution pattern of nanofossils, nanoplanktons based on the these researches. So this vertical show the depth of the sea surface water. So sea surface to 200 meter depth, and lateral side. So this arrow show the warm water conditions. So this side is warm water and this side is relatively cold water. So Florisphaera profunda, like dark area, so deep area, and lower photic zone, and high nutrient zone. So this species living in this zone. On the other hand, almost coccolithophora living in the upper photic zone. So almost coccolithophora like the high light intensity and high light intensity. So and these species are relatively correlated with the warm water species and upper photic zone species. On the other hand, very small coccoliths, including Emiliania huxley, Gephilocapsa, and Reticulofenestra. These species have the size of lower than 2.5 micrometer. So these species is very small. So very small species like relatively cold condition and high nutrient condition. But these species are living in the upper photic zone in sea surface water. Morfino and McIntyre showed the method of reconstruct of the Paleocean based on the thermocline proxy of calcareous nanofossils. So thermocline proxy, they correlated the thermocline proxy with Florisphaera profunda. So this is a lower photic zone species. They showed how to reconstruct of the sea surface condition. Sea surface condition means the sea stratify or vertical mixing. So generally, sea surface means the photic zone. Sea surface to 200 meter depth area have the thermocline and neutrocline like this. So these thermocline, neutrocline is situated usually 100 meters. So this is a normal condition. In this condition, nanofossil assemblages, we can see the nanofossil assemblages like this. Florisphaera profunda, relative percent of Florisphaera profunda is abundant than upper photic zone. So like this. So relative abundance of Florisphaera profunda is higher value than all upper photic zone coccoliths. These, if we can see that these assemblages pattern, so Paleocean condition is like this. So thermocline was situated in the around 100 meters. But now we could see the a lot of upper photic zone species than lower photic zone species. So these assemblages show the thermocline moving. So thermocline or neutrocline situated shallower than this pattern. So why thermocline and neutrocline shallower? So it is due to the upwellings. Upwelling supply the high nutrient and cold water from deep sea to shallow sea surface. Then thermocline and neutrocline move to shallow zone and upwelling supply the high nutrient in upper photic zone. Therefore, upper photic zone species is suddenly increase in this time. Then we can find out this pattern. So upper photic zone, relative abundance of upper photic zone is higher than Florisphaera profunda. So this, if we can see that this pattern, ocean condition as a vertical mixing or upwelling, high nutrient in the upper photic zone. If that this pattern, so relative abundance of Florisphaera profunda is increased pattern, so thermocline is situated deep. Deep is 100, also around 100 meter. So this pattern is a stratified pattern. So this pattern is a mixing pattern. So we can identify these paleoceanographic conditions based on the calcareous nanofossil assemblages. Then I use this proxy. I can reconstruct the paleoceanographic condition. So finally, I show the case study of reconstructed paleoceanographic condition. So this is my doctor's studies, PhD studies in Tohoku University. So title has a reconstruction of paleoceanographic condition in the low to mid-latitude Pacific Ocean using the calcareous nanofossil assemblages. So today I introduce the three-hole nanofossil result, but I mainly introduce the this hole. This hole is situated at mid-latitude Pacific Ocean. So Japan Island here, this hole is situated at the eastern side of the eastern side in the Pacific, Western Pacific, and this hole is situated at Shatsky Light. So this hole drilled at ODP leg 194, and the hole number is 1210A, and drilled at Shatsky Light. So this is a nanofossil assemblages result in Shatsky Light hole 1210A. This number shows the core depth. Almost sea surface floor, depth of 0.3 meter sea floor, and around 10. So I could observe the almost 10 meter course, and I could find out the some of species in this, some of species of calcareous nanofossil in this core, and I illustrated proxy species. So dark blue color show the cold water species. So cold water proxy, Coccolitas pelagix. So this species living in the cold water in modern ocean. So I can use the cold water species as a cold water species proxy. And let show that this and this and like this. Let's show the warm water specimens, warm water species. So warm water species mean the living in the low latitude or warm water current. And light blue shows the very small coccoris. Very small coccoris is proxy as high nutrient condition. High nutrient condition mean so like upwelling or vertical mixing in sea surface. So its condition was supplied high nutrient in upper photic zone. And Emiliana Huxley is living so relatively cold and blooming species. So I compiled these proxy. So green show the lower photic zone species, relative abundance of lower photic zone species. And light green is Emiliana Huxley. So this is a blooming species. Dark blue show the cold water, and red color is compiled of warm water species. And light blue is a nutrient species, and brown show the absolute abundance of coccolith 4. So you can see the drastically change before the MIS 8. So around 250 kilo years. So 250 kilo years means around the MIS 8. So before MIS 8, so like this, high number of before MIS 8, these are characterized by high absolute abundance of coccolith and high value of relative abundance of nutrient species, and a relatively high value of warm water species. Cold water species and lower photic zone species is almost low, so very low value. On the other hand, after MIS 8, so above MIS 8, absolute abundance of coccolith is suddenly decreased. So its value showed very low. And relative abundance of nutrient species is relatively decreased, but this peak shows a high value. Warm water species show the constantly before MIS 8, after MIS 8. So this relative value show the constantly, relatively high. On the other hand, cold water species, this species has slightly increased after MIS 8. And drastically change of the relative abundance of lower photic zone species. So lower photic zone species suddenly increase after MIS 8, and these species show the increase in the interglacial stages, like this. So these assemblages is very good suggestion to the reconstruct paleoceanography. So I can reconstruct the paleoceanographic condition, so sea surface condition based on these assemblages. So before MIS 8, high productivity of the coccolith and high value of small coccolith. So small coccolith means the nutrient species, proxies. So, and relative abundance of warm water relatively high, and low value of cold water and photic zone species, lower photic zone species. So these results show the weekly vertical circulation in this time before MIS 8. So weekly vertical circulation is likely stratified surface. surface layer and high productivity. So this means the blooming or nutrient supply in the surface water, and but not vertical or upward in this time, and the influence of the cross-show current in this time. On the other hand, after MIS 8, so low value of Kokkoris productivity and low abundance of relative abundance of nutrient proxies suddenly decrease, and warm water species also constantly high, so continue to high value, and relative abundance of cold water species slightly increase, and suddenly high value of lower photic zone species after MIS 8. So these result leading strongly seasonal prevalence. So strongly seasonal prevalence means that summertime and winter time is showing in after MIS 8 in this area. So this means the modern seasonal factor is established after the MIS 8, and showing the winter monsoon effect or cold current in the Shatsky rise. So winter monsoon and summer monsoon is established after MIS 8, or cold water current. So more northern current, Oyashi current reached in Shatsky rise. So relationship with these nanofossil assemblages. So Yamane-san clarified some of geochemical values. So he found out calcium carbonate contents at the opal contents and terrestrious matter percentage in Shatsky rise. And this figure shows the Kokkoris absolute abundance. So before MIS 8, calcium carbonate is relatively high than after MIS 8. And after MIS 8, opal content, so opal means SiO2 content is increased than before MIS 8. So these value is concordant with the result of Kokkoris abundance, Kokkoris assemblages. So therefore, we can understand paleoceanographic condition before MIS 8 in this area. So high value CO3 and low value opal and terrestrious matter show the weekly winter monsoon. So it means just not establish the winter monsoon before MIS 8. And after MIS 8, decrease carbonate calcium and increase opal and terrestrious matter. So these result leading strengthening the winter monsoon. So winter monsoon established after MIS 8 in these regions. So this is a schematic images of this area. Conclusion of this this research. So before MIS 8, high value of photic zone species. So this species is a blooming species in this period, and the high value of calcium carbonate, and so these results show the high summer monsoon period and low seasonality in this time and weakly stratified through the sequence. On the other hand, after MIS8, seasonality is strongly. So summer monsoon and winter monsoon is established after MIS8. And in the winter time, in this area, it's have the vertical mixing in this area, and but always the influence under the Kuroshio current in this area. And I observed another ODP hole, so in the Pacific Ocean. So I could observe the hole 846B in the off the Peru and hole 807A in the Ontonjawa Plateau and hole 1210A. So now result. So today I show only result of the only conclusion of this research. So before MIS8, so MIS8 to 14, equator area. So this is off the Peru and this is Ontonjawa Plateau. So this area have the La Nina-like condition before the MIS8 to 14 based on the calcareous non-fossil assemblages. So I can reconstruct the these paleoceanographic condition. So thermocline situated a very shallow position and high nutrient supply into the upper photic zone before MIS8 in of the Pacific, of the Peru area. On the other hand, Ontonjawa Plateau, so Western Pacific warm water pool area, WPWP area, shows a very low nutrient condition. So this area have the very thick warm water in sea surface water area. So thermocline situated more deeper, so more deeper than 200 meter in this time. So these situation can be correlated with modern La Nina-like condition. So in this period is strongly La Nina-like condition in equator. Conversely, after MIS8, these area influenced by the El Nino-like modern El Nino-like condition. So upwelling is upwelling strength is in decrease in the off Peru. Thermocline is moved to deeper position than this, than before MIS8. On the other hand, WPWP area, lower photic zone species drastically increase, and upper photic zone species is very low value. So this these assemblage mean the thermocline is situated general position. So general position means the 100 meter. But WPWP area have the always thick warm water sea surface, warm water in sea surface. So then thermocline is situated 100 meter depth in El Nino period. So this means the weakening the trade window and weakening the upwelling in Eastern Pacific equator, and thick warm water sea surface as a thin condition. So this is a El Nino like. So this is a conclude. Before MIS 8, North Equatorial Current is very strong thing, and trade wind is very strong. So these NEC current, North Equatorial Current strength, and trade wind is strength, leading the strength of subtropical circulation. And this circulation leading the stratified condition in sea surface water in this period in low to mid latitude. On the other hand, after minus 8, North Equatorial Current is weakening, and the subtropic circulation is weakened. So this condition leading the establishment of Asian monsoon, so winter monsoon and summer monsoon in mid-latitude areas. So this is a summary of today's presentation. Calcareous microfossil, especially the nanofossil assemblage analysis, can be useful to reconstruct the paleoceanographic conditions. And in the Pacific Ocean, the ocean circulation strength was changed by the influence of Asian monsoon and trade wind strength before, after, MIS 8. So we can use the microfossil assemblage, so including not only calcareous nanofossil, also like planktic foraminifera as the proxy of paleoceanography, good proxy of the reconstruction of paleoceanographic conditions. So if you have the interested in this analysis, so please come to Japan University. So Kochi University and Akita University can be studied these microfossils analysis. So please exchange and please try to study microfossils. Thank you.
Yeah, thank you very much, Chionobu Sensei. So maybe we will now take a question from the audience, Sensei. So some of question from audience is already covered here. So for the Mr. Hedison, I think for this research is conducted on the 500 kilo years. That means in the Martini zone is NN 21 and 20, yeah, 20 Sensei, for the zone. If in the 500 kilo years, it means in the NN 21 and NN 20 in the based on Martini zone, Sensei.
It means the zone of Martinis.
Yeah.
So most upper part of the Martini zone. So
Okay.
NN 20?
Yeah, and 20 and 21, yeah.
Yeah. 21, yes.
Okay. So and also the next question, Sensei, how is the interval of core to take a sample for nanofossil research? So maybe 10 centimeter or more than 10 centimeter for the...
in the Shatsky, so hole 1210 is 30 centimeter. 30 centimeter.
30, okay.
But Ecota area. In Ecota area, I took the sample in the 10 to 5 centimeter intervals.
Okay, so that means it depends on the condition, yeah.
Yes,
So
it's depend on the sedimentation rate.
Okay. So for the next is, yeah, that is already explained, I think before. Is there any other proxy besides nanofossil in the research to reconstruct paleoceanography?
Sorry?
Yeah, is there any other proxy besides nanofossil to reconstruct paleoceanography? Yeah, maybe foraminifera, sensei.
Yes.
Yeah,
exactly. So in this study, I collaborate with planktic foraminifera researcher, and we compiled the result of between the calcareous nanofossil and the planktic foraminifera and another geochemical data. So it is a very important thing. So we need to collaborate with another fossils and another organic geochemistry for the reconstruction of paleoceanographic condition.
Okay, Sensei, thank you. Bulia, is that clear, Bu? Okay, I think yes. So the next question, Sensei, is the coccoliths abundance would also become an indication for the increase in the sedimentary organic matter or no?
Yes, it is. Of course, not only coccoliths, also another microplankton. But coccoliths has a very big volume in the surface plankton. So in carbonate area, so carbonate area means like open ocean area or low latitude region, coccoliths is very important thing, important plankton to sink the organic carbonate.
Yeah, okay, Sensei. So that means the productivity of coccoliths is also will be the one of characteristics for the organic nature.
Yes, exactly.
Okay. The next question is from Eldo. Eldo already raised hand. Okay, Eldo, maybe you can.
May I speak because my questions could be
okay.
a little bit longer. Thank you for the great presentation.
Thank you.
But I would like to ask something related to this weak stratification that you mentioned before the 250,000 of years, because as you said that the core interval is based on the sediment rate, then I was thinking maybe the core in above range might be a little bit more smaller because we have, I don't know, more newly sedimented material. So I'm wondering whether the interpretation that you conclude stating that weak stratification is only based on this lower and upper photic zone species, or was it like several parameters?
So it means the now my research result, my research summary was only nanofossils, so isn't it? So actually today I talk about only calcareous nanofossil assemblages, but I have the a lot of another data. So because ODP and IODP project joined a lot of researchers. So these researchers, including the geochemistry or another microfossil researcher or magnet stratigrapher or and more. So we can use these data for our study, and we we can compile a lot of data based on the calcareous nanofossil assemblages.
Okay.
Now, then we can clarify the condition of paleoceanography.
So that about the high nutrients layers is like combination, because I was thinking if it's like based on fossil only, both foraminifera or nanoplankton, I was thinking it's like if we go deeper into the sediment, maybe there is more how to call it, aspect to add to that, like dissolution of the shells and preservation might also plays in that role. Do you think that it also can add something to this result? Because I think I might need this perspective for my upcoming project, because I'm most probably working on the high nutrients species of plankton as well.
Yes, of course, plankton or another chemical. So like the calcareous nanoplankton or have the dissolution into the water columns and surface of seafloor. So generally, it's remained 40% of calcareous nanofossils in sediments by the dissolution. So because bottom water of open ocean is have the high oxidation condition usually. So then calcite is dissolved into water column. But amount of sinking of calcareous nanoplankton or nanofossils is very high, very high. Then they remain high. They remained big volumes in sea bottoms, and we can use these data. Of course, a lot of fossils and a lot of organic carbonate is dissolution.
Okay, may I add one short question, or is it? About this lower photic species, are they like, because it's new to me, I thought all coccolithophores are phytoplankton. Are they still performing photosynthesis or just living under the limited sunlight thing?
Yes, but the lower photic zone species is living in the equator to mid-latitudinal regions in lower photic zone. But this area limited in open ocean. So, for example, like Japanese island or Indonesian islands have the very shallow marines below island. So these shallow marine lower photic zone species cannot live in very shallow marines.
Okay, thank you so much.
Yep.
Yeah, thank you, Mr. Eldo. I hope that answer can be good for you. And I know Mr. Eldo is one of marine micropaleontologists and say in the Europe Research Center. Yeah.
Oh.
Thank you very much, Mr. Eldo. So maybe this is the last question, Sensei. And the last question is:
okay.
There are the ODP and IODP institution. What the difference between these two institutions? So what is different between ODP and IODP, Sensei?
This question for the Ikehara sensei.
Yeah.
Maybe. So ODP and IODP probably likely same projects, but ODP was mainly United States, but IODP is completely collaborate of Europe, United States, and Japan project.
Okay,
Probably.
Yeah. Okay, I think that is clear. So, from the audience, anyone have more question? From student, from lecturer, from our college? Yeah, I think no more questions, Sensei. So, thank you very much. Maybe
Okay, thank you.
Yeah, I can conclude for today a lecture from Dr. Sunshio Nobu. So, if I can conclude, so coccoliths is one of the phytoplankton. This is considered to be sensitive to change in the sea surface temperature and also in the nutrient condition. So, as description, nanofossils is not just for biostratigraphy, but also for the reconstruction of the paleoceanography from the Mesozoic until the recent age. So, based on the research from the Chionobu sensei, we can conclude the difference of geographic distribution pattern of calcareous nanofossil assemblage in the sedimentary record. In this case, he used a core sample. So, for the pattern of calcareous nanofossil assemblage in the sedimentary core sample has been controlled by the condition of the sea surface, such as water mass, and related with the global climatic event response. So yeah, I think that is all. Thank you very much, Dr. Sunshio Nobu. Maybe before we are closing, we want to give a certificate to Dr. Sunshio Nobu as our appreciation for the today lecture. Maybe I will give to the MC, Ms. Kamala.
Okay, thank you very much, Dr. Aingsanti Dwi Pratiwi, and also thank you, Dr. Sunshio Nobu, for your great presentation. And as our appreciation, we will give a certificate that will be given by Vice Dean.
Thank you very much, Ibu Kamala. To Professor Sunshio Nobu, Associate Professor Sunshio Nobu from Akita University, on behalf of our faculty and engineering geology, we would like to say thank you for your contribution as an invited speaker in our webinar series this afternoon. So I would like to present this digital appreciation to you. Yeah, later on our faculty members will send the original to you if it's necessary, important for you, the original one. So I will send it to you. Please receive our appreciation for you, and thank you very much again for your contribution to our faculty. Thank you.
Thank you. Terima kasih.
Sama-sama.
Terima kasih, Sensei.
Thank you so much for Professor Megha Fatima Rosana, our Dean of Faculty. Once again, thank you, Dr. Sunshio Nobu. So ladies and gentlemen, before we go to the last speaker, maybe we can take a photo together so all of the participants can turn on your camera. Okay, I'll count. 1, 2, 3.
Teknik Geologi Universitas Pajajaran merupakan lembaga pendidikan tinggi yang menyelenggarakan dan mengelola 3 program studi, yaitu program sarjana dan program pascasarjana yang terdiri atas program magister dan program doktor dengan didukung oleh 8 orang profesor dan 37 orang dosen sebagai staf pengajar. Fakultas Teknik Geologi dengan visi menjadi fakultas yang berstandar internasional dan bermanfaat bagi masyarakat. Salah satu tugas pokok dalam kurikulum teknik geologi adalah menciptakan lulusan yang memiliki keunggulan dalam kemampuan lapangan. Sehingga kurikulum teknik geologi dikembangkan secara terpadu dengan muatan desain penelitian, baik berupa pengetahuan, keterampilan maupun pengalaman penelitian dalam bidang geologi. Sehingga mahasiswa bebas memilih dengan outcome yang lebih baik sebagai bagian dari program Merdeka Pembelajaran.
All right, ladies and gentlemen, so our last speaker today is Dr. Tekuyan Walyana Muda Iskandarsyah from Faculty of Geological Engineering, Universitas Pajajaran. I'll read his biography. So, Dr. Tekuyan graduated from Universitas Pajajaran from his bachelor degree in hydrocarbon determination, and his master degree is groundwater contamination from Institut Teknologi Bandung. And he finished his doctoral degree with theme 1883 Krakatau Tsunami from Université d'Estrades, France. And his research and also publication is all about groundwater. And for today, his specialist is environmental geology, and his topic today is coupling Ujung Kulon tsunami deposits and the past event of 1883 Krakatau eruption. Before we start, I would like to inform you, if you have any question during the explanation from Dr. Tekuyan, please kindly use Zoom chat features or raise hand feature. All of your questions will be answered by Dr. Tekuyan in discussion session. So good afternoon, Dr. Tekuyan.
Good afternoon, everyone.
Okay, time is yours.
Okay. Thank you for this opportunity. Thank you for the time. Good afternoon, everyone. I hope in this afternoon it's still interesting to talking about the geology today in this Saturday afternoon. So I will talking about the title and yeah, maybe perhaps it's not directly relates to the main topic about the paleoceanography and global climate change, but and also it's quite different with two previous speakers, but I hope it's still interesting because one of the geological phenomena in the past, Krakatau eruption, has changed the global climate at the time. So this is very interesting. Then I will starting explain about the tsunami, and then after that coupling the tsunami with the eruption in 1883. So I will share the slide. Can you see my slide?
Not yet, Pak.
Not yet?
Yeah.
Sorry.
Yeah.
Okay.
Sudah.
How about now? Yes.
Yeah.
Okay. This is my title in this afternoon. I will explain about the coupling Ujung Kulon tsunami deposit and the past event of 1893 Krakatau eruption. One of the events that changed the global climate at the time. Yeah, as we know that Krakatau eruption on August 1883 had affected global climate and triggered several tsunamis that destroyed the shore of Sunda Straits. Yeah, in this century, there are two enormous eruptions in Indonesia, Krakatau and Tambora. But Krakatau is one event that affected the global climate and triggered tsunami, a big tsunami at the time. The reconstitution of this part event characteristic might be done on the basis of deposited tsunami sediment. So I will explain about the layer of tsunami found at Ujung Kulon Peninsula. Yeah, according to its unique coastal morphology, Ujung Kulon Peninsula has a significant influence on the characteristic of sediment record of this event. So this is very interesting that in this area we found a thick tsunami deposit, and then the configuration explained about the tsunami event and tsunami eruption at the time. This is the study area. Krakatau is in the middle of the Sunda Strait, the Krakatau volcanic complex, and then the Ujung Kulon Peninsula. When we found the tsunami deposit is in the south of Krakatau volcanic complex and the end of the Java Island. In this research, we applied some method that we combine some analysis to analyze the deposit. But before that, we conducted interpretation of aerial photos or satellite images to identify potential sediment traps. So we looking for the area that potential for sediment traps to the tsunami deposit. And then after that, field investigation were carried out by coring or trenching. And also in laboratory, we carry out the laboratory analysis for the sediment sample collected in the field related to the grain size, identification of microfauna, anisotropy of magnetic susceptibility, petrography, and geochemistry. So this research is a combination of the several analyses in the laboratory. And the work that we study the correlation between sediment profiles of local morphology. This is the investigation site. We made the transect in the Laban Isthmus, the narrow area in the Ujung Kulon Peninsula between the peninsula and the end of the Java Island here, Mount Honje area. All the area is included in the Ujung Kulon National Park. So this is there were drilling site, transect site, trenching site, outcrop site, and other observation site for the tsunami deposit. This is the tsunami deposit that interesting. We focus the tsunami deposit in the end of in the west area of the Ujung Kulon Peninsula, near the Pecang Island, and then in the narrow area of the Laban Isthmus here. There are a transect consists of 6 drilling sites. This is the result of the grain size analysis. From this profile, you know that there are 4 layers of tsunami here. One in the base of the profile, content of ripped up class here, and then the shell also, and pumice. This is the K axis. K1 axis is the long axis of anisotropic of magnetic susceptibility. Its layer we analyze the anisotropy of magnetic susceptibility to identify the K1 axis to know that how the tsunami deposit, the tsunami flow at the time. So based on this axis, we know that the flow direction at the time. This is the mean size, standard deviation, skewness, and kurtosis to identify the sequence of tsunami. So based on this grain size analysis, we have identified the 4 layers of tsunami in section 1 here. In section 2, there were also 4 tsunami deposit here based on this grain size analysis. But the K1 axis cannot be analyzed because the sediment is coarser than the section of U1. So it's difficult to analyze anisotropic of magnetic susceptibility. This is the section of U3. In this section also there are 4 tsunami deposits here. And this is a section of U4, it's the same. But in this section, we found many of, we conducted many of anisotropy of magnetic susceptibility with K1 axis like this figure. This is the section of U6. If we see in this picture, U5, sorry, U5 is near the Indian Ocean. This is the section of U6. Is maybe about the 100 and 200 meters near the Indian Ocean. So this is different with another section because, but there are 4 tsunami deposits also. But after we analyze this axis, we can conclude in this another slide that it's not the different direction, one each other between its section. This is section U8, but this is far from this another section. It's just one section in the west part of Ujung Kulon Peninsula. So this is the result of foraminifera analysis. First, several foraminifera have been identified within the tsunami deposit plates at Laban Isthmus. Elphidium lesonii, Planulina wullerstorfi, and Strabulus beccarii are the benthic foraminifera that were found in section U3, U4, and U5 respectively. This foraminifera abundant found in this section because this section is situated in the middle part of Laban Isthmus. So the environment at the time is more calm than the U2, U1, or U6. Yeah, it's more calm or more, yeah. The energy of the tsunami is decreased in this location. So foraminifera will be found abundance in this area. From this foraminifera that we found, we conclude that based on Elphidium lesonii and Strabulus beccarii indicate that the tsunami eroded the ocean floor of the shallow marine environments, while Planulina wullerstorfi were derived from the deeper ocean environment, upper Bhatia. So this is very important because Laban Isthmus is the area that influenced by two flow between Sunda Strait and Indian Ocean, because this area just 1 kilometer wide, 1 or 2 kilometer wide, and then in the Ujung Kulon Peninsula. This is the result of anisotropy of magnetic susceptibility. In general, the L, F, and T values indicate that the magnetic tissue is predominantly flattened. L is less than F, and so on, with variation in their elongated component. The implication angle are generally less than 20 degrees, with some variation between 21 and 41. The axis, but the important things that the axis of K1 showed that the sediment were put in place by two general flow directions. The first direction propagates between N 104 and N 262, the tsunami sequences. Between N 122 and N 236. The second in the opposite direction between N 280 and N 80, while the tsunami sequences is between N 318 until N 58. This is the figure that we can see in this figure about the ellipsoid axis of the first sequence here. So in this area U4, we can see in this ellipsoid an isotopic of a magnetic susceptibility. We can see that the flow direction is coming from the north. But in the other hand, there is also the flow coming from the south. The same also in the U6 here. There are two directions coming from the north and coming from the south. This is the second sequence. In this site, we can see that there are two different flow here, direction of flow, coming from the north and coming from the south. There are also in the third sequence, there are two opposite direction here in some site. This is also in the fourth sequence. So we have to correlate the profile, the layers of tsunami deposit, both from the Sunda Strait symbolized by TSSS, tsunami Sunda Strait, and the Indian Ocean, symbolized by TSIO. So essentially the same texture and composition of the sediment. So the tsunami is the same, texture and composition of the sediment is the same, both from the Sunda Strait and Indian Ocean. So we difficult to compare or to distinguish between the tsunami Sunda Strait or Indian Ocean by based on the grain size analysis. But we have to use the foraminifera and NS value for identified of for identify the direction of the tsunami deposit. Correlation showed that the isthmus of Laban recorded no less than 8 sequences of marine evasion. Here, the simulation of the correlation here. This is the pre-1883 base layer of Laban Isthmus before tsunami coming here in this area. And this is the first sequence of tsunami coming from Sunda Strait here. And after that, in the top, covered by the layer, the thin layer coming from Indian Ocean. After that, in the second sequence, you can see here, there are the thick layer coming from the Sunda Strait and covered by the thin layer from Indian Ocean. And this is the third sequence, the layer coming from Sunda Strait here, the big, the thick thickest layer coming from Sunda Strait, and the thinnest layer here coming from Indian Ocean. And the last sequence here is the thin layer coming from Indian Ocean and from Sunda Strait and coming from Indian Ocean in the top. So this is the problem. Are the tsunami deposits found at Ujung Kulon, including the deposit at the southern coast set up by the Krakatau tsunami in 1883? Because this area is also can affect by the tsunami coming from Indian Ocean that not relates with Krakatau eruption. So the question is, are the tsunami deposits found at the Ujung Kulon, including the deposit set up by the Krakatau tsunami or Krakatau eruption in 1883? This is the first question that we have to solve this problem. So we compare with mineralogy and geochemistry. So we saw that the glass particles are not present in great abundance, less than 10%, and apparently modified in clay minerals. The minerals identified are feldspar, orthopyroxene, and opaque minerals in accordance with previous description of the pyroclastic deposit of Krakatau in 1893. There was some researchers that analyzed the mineral from the ice, volcanic ice. So we compared that the mineral identified in accordance with this previous research. The main elements, namely SeO2, TiO2, Al2, and so on, demonstrated a similar percentage with previous description by Verbeek and Simon et al. This is the result of the geochemistry. You can see here, Ujung Kulon volcanic ash here that we identified is in accordance. It's similar with the chemical composition of dust fell at Buitenzorg or Bogor. Now we can now the city is Bogor, not Buitenzorg again. This is quite similar with the previous research here. And also the geochemistry for this sample is similar for Ujung Kulon volcanic ash that we have identified with the chemical composition of dust analyzed by C. Winkler, which was found near Krakatau or found at Bogor. And this is relationship between the distance and SiO2. Yeah, this is for Krakatau in about 60, and this is for U3 and U6, and then this is fell at Bogor. The distance we can see here. Yeah, the distance and the peaks of SiO2, but it's the same with the U3 here. And then how is the same? So based on this result, we know that the tsunami is coming from tsunami deposit is coming from Krakatau even in 1993. So how is the same in case they could be deposited in coast that is not open to Krakatau? This is the effect of coastal morphology. So we have to see the morphology. The plain morphology of the Laban Isthmus may have caused by the 1893 Krakatau flood tsunami then spread over any isthmus, because the Laban Isthmus is face directly to the Krakatau, but open directly to the Krakatau. But for another area, tsunami waves from Krakatau have been refracted along the western coast because tsunami has behavior to refract, reflect, and diffract. So in this case, that tsunami in the end of Ujung Kulon Peninsula have been refracted along the western coast. So why in the south of Ujung Kulon Peninsula there are also some deposit of tsunami from Krakatau. This is also supported by numerical simulation of split tsunami during the Krakatau eruption, so that tsunami waves emerging from the Sunda Strait were refracted eastward along the Ujung Kulon Peninsula. Yeah, this simulation was done by some researchers like Yokoyama, Mamamboy, and Maino and Imamura. This is the effect of coastal morphology. We see here the continental slope in the south of Ujung Kulon, and this is Sunda Strait, is shallow marine here. And this is how the tsunami infested the Ujung Kulon. This is the flow direction here, and refracted in the end, in the western end of Ujung Kulon Peninsula. Refract, and then distress again in the south of Ujung Kulon Peninsula, inundated the area of Laban Isthmus from the south direction. And the third question is, could the configuration of the tsunami deposit found in the study area be linked to the different eruptive phases of the Krakatau eruption in 1893? Okay, there are 4 gigantic explosions from Krakatau on August 27, 1893. And also the Royal Society Krakatoa Committee reported the possibility of 4 tsunami sequences based on pressure gauges at the Batavia gas plant. So based on this report, we know that there are 4 tsunami sequences. And then the Laban Isthmus recorded no less than 8 sequences. By our research, we found that no less than 8 sequences of marine invasion caused by eruption, which actually corresponded to 4 tsunami. So the important thing here that there are 8 sequences, but correspond with 4 tsunami. So there are double recorded in this area. This is the scenario at 6 o'clock until at 6:30. The tsunami, the first tsunami is coming from north and inundation the Ujung Kulon or Laban Isthmus here. And the tsunami refracted in the western part of Ujung Kulon Peninsula, and then inundated also from the south 5 minutes after the first tsunami inundation here. And then this is the first tsunami event. And then if we coping this tsunami event is triggered by first eruption from Danang explosion, and after that in 7:30 after 7:45 there are also a second tsunami wave bigger than the first tsunami here, inundation the Laban Isthmus and Ujung Kulon Peninsula, and refracted 5 minutes after the first tsunami in the second event, inundated from the south direction here. And then this is caused by perbuatan explosion at that time. And the third event is the tsunami bigger than previous tsunami. In this tsunami is triggered by Krakatau or Rakata. Yeah, the big mound in the Krakatau volcanic complex at 10:30 after until 11, and then refracted in the western, and then inundated from the south in this area. And the last eruption and the last tsunami is coming from north, and then after that coming from south. So this the double event, double tsunami in one event. So this is the situation of the topography before the tsunami, and then in the above, this is the topography after the tsunami. How is the effect of coastal relief to the configuration of tsunami deposit multiple sediment clogging? We can see here that due to the coastal relief, there was very minor or no erosion between successive waves at Ujung Kulon Peninsula, because this area is Ujung Kulon National Park. So there are no people here. So there are no also the development of the area. So there was very minor or no erosion here. The narrow plain of the Laban Isthmus caused the deposit probably come from two opposite directions of tsunami waves, from the Sunda Strait and from Indian Ocean. And the northern part of the coastal plain of the peninsula is formed by a large and shallow continental shelf with two face-shaped bays, which can act as a wave trap. So in the northern part of the peninsula, there are two face-shaped bays. Then so this morphology form is unique than another morphology, coastal morphology. Then this unique morphology is potential for tsunami to deposit this the sediment in this area, because the energy will focus or will trap in this area. And then the morphology of the southern coast consists of a narrow continental shelf and steep submarine slope that can reduce the threshold shear speed of tsunami waves. Different with the tsunami coming from the north. The tsunami coming from the south, the energy is less than the tsunami from the north. This is the configuration of the tsunami between the north and the south. So this is the V-shaped bay here, welcome bay in Laban Isthmus. So the tsunami coming from the north is will directly to Laban Isthmus here, make a strong energy in this area. So this is the figure that we can see the proximal, medial, and distal from the Sunda Strait here, and then the hydrodynamic tsunami process here, from rolling saltation here and suspension in the distal near Indian Ocean. But on the other hand, there are also tsunami coming from Indian Ocean. This is rolling and saltation here, and suspension in the distal here. So the site in each area, they have two condition, distal and proximal, depend on the tsunami coming from Indian Ocean or Sunda Strait. This is the epicoastal morphology based on mean grain size here, the distribution of the grain size here. You can see that the U1 is coarser than U3 or U4 here. U3 or U4 in from mean grain size is more is less than 100 micrometer. This is Manning maximum distance. If we see that the Laban Isthmus is composed by palm tree here, we can put the Laban Isthmus, the point in between N 0.07 until 0.03 here. So we can determine that the maximum distance of flooding is less than 2 kilometers, not more than 2 kilometers. This is the correlation of stratigraphic here. You can see here the biggest tsunami deposit here correlate with the biggest explosion of Krakatau in 1883. At 10 a.m. at that time, Krakatau local time. So the conclusion here, we can know that the main feature of the Krakatau tsunami deposit found at Ujung Kulon is the presence of individual stack sequence represented by unit of normally classified bioclastic sand and volcanic material contained within certain sequences. So we have to identify pumice and shell in this layer. So we know that this is the tsunami deposit. And then several sequences of tsunami deposit have been identified at Ujung Kulon Peninsula, which demonstrate the mixing process took place between two different phases of sediment transfer from Sunda Strait and from Indian Ocean. Ice invasion corresponded, in fact, to 4 tsunami. So in this area, there are ice invasion corresponded to 4 tsunami. 4 tsunami is corresponded to 4 eruption of Krakatau in 1883. The contrasting thickness of the third tsunami coming from Sunda Strait might be produced by enormous explosion of Krakatau, which affected the global climate later. And then tsunami sequences can be identified with precision using a multidisciplinary effort beyond sedimentology and stratigraphic approach. And the one important thing that IMS technique supported by identification of foraminifera are decisive in detecting the magnetic fabrics. So we can know the direction of the tsunami, direction of the tsunami flow in this area. So this is the insufficiency. The drilling method, which was applied for the first time, has limitation due to the imprecision of the measurement of the azimuth of the sample tube before drilling, and the possibility of disturbance of the sample during. And then sampling for AMS, a fully sorted sediment is not possible So in U2, U1, we cannot conduct it, the AMS here, because the fully sorted sediment is not possible. Because particles can disrupt the initial sediment fabric and sink in the sample boxes. For the perspective, using larger boxes would require a measuring device suitable for large boxes, and then carry out further study and wider stratigraphic correlation around this unique exceptional site for tsunami records. And the last, underwater sampling could also be a very valuable and complementary input to validate the analysis of foraminifera in tsunami deposit that were deposited far inland. Okay, thank you very much for the attention and the time. I will back to the moderator.
Thank you so much, Dr. Tekuyan. In summary, several tsunami was triggered by Krakatau eruption that also affected the global climate change. It can be seen from unique coastal morphology and its foraminifera. From Dr. Tekuyan research, we can see that the fossil also indicate the direction of flow from tsunami. Some fossil indicate which position of land that eroded and bring the fossil material. Also, the simulation represent the spreading of tsunami flow through coastal area. So we'll start the discussion or Q&A session. Maybe I will welcome Pak Awang. Pak Awang here give some question. Maybe Pak Awang can turn on the camera and the microphone so you can directly ask Dr. Tekuyan. Please welcome Pak Awang.
Okay, thank you, Mbak Kamala. Thank you, Mas Yan.
Yeah.
A good presentation and good record of the tsunami deposits in Laban Isthmus. I would like to ask you about the past volcanic eruptions because before 1883, the Krakatau also ever erupted catastrophically, at around 400 or 500 years AD. So your study focused on the tsunami deposits because of the eruptions of 1883, right, in Tanjung Laban by drilling several wells and check the materials. My question is because Krakatau also ever erupted catastrophically at around 400 or 500 years, 400 or 500s, and in it could also generate large tsunamis and maybe can also impacted the Laban Isthmus at that time. So if we drill several wells deeper in Laban Isthmus, could we have also tsunami deposits as also you concentrate on 1883 tsunami deposits? And also, did you also do the carbon dating for samples deposits that you encounter on wells?
No. Yeah. Thank you, Pak Awang. This is at the first. I like also to know about the Krakatau eruption in 400 years, because this is very interesting to prove. Is there any eruption before? Is there any big eruption before 1883? So for the first to conduct this research, this also based on the curiously to know about this previous Krakatau eruption in 400 after 400 maybe. This is the big eruption. But unfortunately, we cannot do the carbon dating at the time when I was collected the sample, because because I have combined some analysis, grain size, foraminifera, IMS, and geochemistry, but one of the method we cannot do that carbonating. But if we do the carbonating, I think the result will be better than our research. So this is our plan to the future to do the carbon dating for this sample.
Yeah. The wells you drill is quite deep, yeah, around 200 until 300 meters deep. And is it possible so that
2 meters?
2 meters?
2 meters, not 200.
Oh, 2 meters.
2 meters, just yeah.
Okay. Oh, just 2 meters, not until 100 meters.
No.
Okay.
Just 2 meters.
Yeah.
So we have to make a deeper drill in this area
drilling.
to know the past even before 1893.
Yeah. Because maybe the Laban Isthmus existed for a long time. Yeah,
yes.
Even before 1883. Yeah.
Yes.
I think the eruptions of Krakatau at 400 or 500 maybe bigger than 1883 yes. Because it formed the Sertung Island, Panjang Island, and Krakatau Island.
Yes.
So it should be big tsunamis, and also maybe we have also tsunami deposits that can be analyzed as your method showing, but we need deeper sections. Yeah. Okay. Yeah. Thank you.
I agree with you. Thank you very much.
Yeah.
Thank you very much for Pak Awang. Maybe other participants have any question? If you have any question, please use the Zoom chat or raise your hand.
May I ask one question, please?
Please welcome Prof. Ildram.
Thank you, Ms. Kamala. Pak Yan.
Yeah, Prof.
Looking at the geochemical data of the U06 sample, it shows that the SeO2 content is relatively more higher from the other sample. I think about 72%, I think, yeah, which means it's more acid than the other sample. Just right?
Yes.
I think it's indicate the eruption more large, more higher than the other eruption. That's right?
Yes, but maybe.
Okay. I continue my questions. My question is, did the eruption produce a tsunami layer indicated by that sample more deep or more deeper from more the thickness more higher than the other layers?
Okay. Yes. U06 located at near the on Indian Ocean, Prof. Yeah. So maybe there are also some added mineral or SO2 from Indian Ocean, bigger than the U03. The mineral from near with the Sunda Strait. So maybe this is the cause why SeO2 in U06 is bigger than U03, and it's bigger than the volcanic ash fell near Krakatau or Bogor. So it's not about the thick of layer only, but there is also the influence of flow or tsunami there, because in this area there are double direction of tsunami.
Okay.
Area. So
okay, thank you, Pak.
Maybe the U06 is influenced also by Indian Ocean, the mineral from Indian Ocean.
Okay, thank you.
Yeah, you're welcome.
Thank you very much, Prof. Ildram, for the question. Maybe another participants, if you have any question, you can ask Dr. Tukuyan directly or just write in the Zoom chat.
Makan dulu dong.
Okay, maybe there's no more question, Dr. Tukuyan.
Okay. Thank you very much.
Thank you so much for your wonderful presentation, Dr. Tukuyan.
You're welcome.
We will take a photo together so all of the participants can turn on the camera. Are you ready?
Yeah.
All right, for the operator. Let's take a photo together. 1, 2, 3. More photo. 1, 2, 3. All right. Thank you so much for all the participants and for all the speakers today. So we will give a certificate for Dr. Tukuyan. As our appreciation, the certificate will be given by Dean of Faculty of Geological Engineering, Universitas Padjadjaran.
Pak Tengkuyan, thank you very much for your contribution.
You're welcome.
Our webinar series, international webinar series. So on behalf of Faculty of Engineering Geology, we would like to present this certificate appreciation as your contribution. Please receive our digital certificate for you. Thank you very much.
You're welcome. Thank you very much, Prof. Nick.
All right, thank you very much, Professor Mega Fatimah Rosana, and also all of the speakers today. We are at the end of our webinar series number 2 with topic Paleoceanography and Global Climate Change. Hope this will be a huge benefit for all of us. And once again, I would like to say thank you to all of our keynote speakers and also our moderator. Thanks for sharing with us and thank you for taking time out of your busy schedule. Before I close this event, I would like to inform you that this webinar series is a part of 62nd Natalis or anniversary of Geological Engineering Faculty event that held every Saturday. So please join our next webinar in next Saturday here. International Webinar Series 3 with topic Contribution of Human Resource Development in Monitoring Environmental and Climate Change for Sustainable Development Goals in Saturday, 9th October 2021 with speakers Kang Kun Lee, PhD from Seoul National University, Korea, and Kazuyo Hirose, PhD, Director, International Cooperation Department, Japan Space System from Japan. All right, last but not least, thank you for all of the participants in this Zoom meeting and on YouTube Live. We look forward to seeing you at the next event. I'm so sorry if I made mistake. It has been my pleasure to host this event. We wish you all a pleasant day. See you on next webinar and thank you.
Para pembicara, panitia,
Recording stopped.
Fakultas Teknik Geologi Universitas Pajajaran merupakan lembaga pendidikan tinggi yang menyelenggarakan dan mengelola 3 program studi, yaitu program sarjana dan program pascasarjana yang terdiri atas program magister dan program doktor dengan didukung oleh 8 orang profesor dan 37 orang dosen sebagai staf pengajar. Fakultas Teknik Geologi dengan visi menjadi fakultas yang berstandar internasional dan bermanfaat bagi masyarakat. Salah satu tugas pokok dalam kurikulum teknik geologi adalah menciptakan lulusan yang memiliki keunggulan dalam kemampuan lapangan, sehingga kurikulum teknik geologi dikembangkan secara terpadu dengan muatan desain penelitian, baik berupa pengetahuan, keterampilan maupun pengalaman penelitian dalam bidang geologi, sehingga mahasiswa bebas memilih dengan outcome yang lebih baik sebagai bagian dari program Merdeka Pembelajaran.